Hello everyone, myself Sandesh Gowda V, studying in Venkateshwara College of Engineering, Department of Information Science and Engineering. Technical seminar topic is Secure Communication in Internet of Drones under the guidance of Professor Chetan C, Department of ISC. Today's contents are introduction, related background, working implementation, feature enhancement, conclusion and references. Introduction to the topic. IoT devices, particularly those with embedded system, are vulnerable to cyber attacks due to wireless communications, necessitating lightweight encryption solutions. Research proposes techniques like elliptical curve cryptography, that is ECC, implementation and DAS and key management protocol to ensure secure communication among drones. Innovations such as certificateless signography, tag key encapsulation mechanism, and machine learning algorithms enhance authentication and key management in secure drone communications. The proposed drone system utilizes ECC based, that is elliptic curve cryptography based encryption algorithm to optimize performance while securing data transmissions to a server across three layers, that is cloud, communication and infrastructure, and efficient message protocol facilitates seamless data transfer between infrastructure and cloud layer secure storage of information collected by the drones. Related background: one paper tells that this paper tells ECC implementation on 32-bit microcontroller. This paper tells that implementation of ECC on 32-bit microcontroller, specifically focusing on nodes in wireless sensors networks, that is wireless without hardware support. And this paper, that is next paper, machine learning and software defined networks for security, use random forest classifier model and SDN to address attacks during data transmission by analyzing traffic. Next, RM RAM IoT for key authentication. This paper tells that a key generation protocol named RA ramp IoT that incorporates ECC to ensure the integrity of data transmitted by drones to a server. Next, working or implementation. This is a drone architecture consisting of three layers, that is cloud layer, communication layer and infrastructure layer. The cloud layer comprises the following components like web servers, that is interfaces the server, and server will be interfaced with the database. And in communication layer consists of communication protocol and key management services, where there will be the MQTT server and MQTT client, where that is used to transfer data between drone and a server. Finally, infrastructure layer contains the drones to encrypt and decrypt data. And this is the key management and key exchange diagram, where in key management the key pair generation and encryption that will be stored in the server, and that using that private and public key the encryption will be done, and the shared key, using the shared key and private key, the decryption will be done, and the plain text will be generated in the user side system. And this is the key exchange, the key exchanges between the microcontroller and server using the MQTT broker. This broker helps to transfer the data between microcontroller and this server. Using public key and private key, the shared key will be generated at the both the ends, and the encryption will be done at the microcontroller side, and the decryption will be done at the server side. Next, Cortex M optimized stack, that is CMOX library, a cryptography library used with STM32, Cortex M based MCU, that is microcontrollers, for the encryption and decryption of the message via API calls, and key generation process. Shared key generation on the microcontroller involves functions like CMOS ECDSA key generation and CMOS ECDH. CMOS ECDH takes the elliptic curve parameter, which can be either, it is NISTK P256 or NISTRP 256 or by brainpool T P512. All of these curves can be implemented with their low RAM or high RAM usage. CMOS ECSDA key generation. Here the generates private and public key provided a random number and a elliptic curve parameter. The private key generated here is used in CMOS ECDH with the server public key, and a shared key is generated. Here whatever the uh, whatever the private key is generated here, that will be used in CMOS ECDH, that is on server side. The server uses the public key and the private key generated here to generate the shared key. And this is the system drone architecture. uh, Wireless communication. This is the microcontroller, that is SM232G4 is the microcontroller that will be interacting with wireless communication by UART and IMU server through I2C and BLD motors through PMV. Encryption of drone data. The 256 bits AES encryption algorithm takes its parameter and shared key generated by ECE. The telemetry drones data as plain text and initialization vector. The output is an encrypted ciphertext. The drone implemented on STM32G4 microcontroller interfacing with IMU sensor through I2C communication and BLDC motors. Data transmission to web servers. Uh, Wireless communication handles by the interface with Modron using the AT command protocol over UART to send encrypted telemetry payloads to the web server using the MQTT protocols, where the MQTT broker is hosted in AWS IoT Core. And the future enhancement of this is the improving the key management services to support larger groups of drones, implementing stronger authentication mechanisms such as multi-factor authentication or biometric authentication could enhance overall security of the drones. While AES is the currently used for encryption, um, future enhancement could involve exploring alternative encryption algorithm that might offer better performance or security characteristics. Conclusion. On conclusion, the feasibility of implementing secure communication techniques in a small IoT system. Designers of small, low-cost IoT devices can implement modern, powerful security solutions using affordable and modern RISC processor. The combination of TLS encryption and end-to-end encryption at both the microcontroller and server side provides an efficient strategy to enhance data security. Uh, these are the references that are used in this, and thank you.